Welcome to today's webcast. This call is being recorded. And now to begin the program, I'd like to introduce Ms. Tracy Cook. Please go ahead.
Thank you so much. Hello, everyone, and welcome to today's Fireside Chat webcast, Database Replatforming, the Last Barrier Between You and the Cloud, sponsored by Datometry. I'm Tracy Cook with Virtualization and Cloud Review, and I'd like to thank you all for joining us. Before we begin, I'd like to take care of a couple of housekeeping details. Please feel free to type your questions into the Ask a Question box on the console at any time during the presentation. We'll address as many of your questions as we can during the live event. The entire webcast is being recorded and will be archived for future viewing, and we'll send you an email when the replay is available, and that should be in approximately 24 to 48 hours, and you can access the replay using the same link you used today. And now I'd like to introduce our presenters for the event. Today's moderator is Trevor Pott. Trevor is a full-time nerd and co-founder of eGreek Consulting Limited. He splits his time between systems administration, consulting, and technology writing. As a writer for Virtualization and Cloud Review, he is keenly interested in the redefinition of the IT industry occurring because of the emergence of public cloud computing and what this means for virtualization administrators and IT practitioners. So Trevor, welcome, and thank you for joining us today.
Thank you very much, and hello to everybody.
Great. We also have Mike Waz, CEO and founder of Datometry, with us today. He has spent over 20 years in database research and development in companies such as Microsoft, Pivotal, and Amazon. Besides the development of Datometry's database virtualization technology, he is the founder and architect of Greenplum's Orca Query Optimizer. Mike has 36 publications on the science of databases and 24 patents to his credit. Welcome, Mike, and thank you for joining us today.
Thanks, Tracy, for the intro. Thanks for hosting us today. Excited to be here.
Yeah, we're happy you're here, too. And so we're in great shape with Trevor and Mike. And now I'd like to turn the event over to Trevor. Trevor, please take it away.
All right. Thank you very much. Before I get started on the interview here, I would like to ask Mike to please give us sort of the elevator pitch description of the company to get us started.
All right. So we are a venture-backed startup. Actually, we just closed our Series A, and we pioneered what we call adaptive database virtualization. We solve what really is kind of the biggest problem, the biggest obstacle when enterprises move to the next generation of cloud. It's no longer so much about compute and storage, but really about how to take advantage of cloud-native data management without having to rewrite, recompile, and reconfigure your entire existing application environment. Datometry effectively eliminates the need for database migration, and instead, with our product, enterprises can move to the cloud at a fraction of cost, time, and most importantly, risk. Even though we're a small startup, we get, as you can imagine, the attention from all the major players in this space already, from Amazon to Google and Microsoft, from Pivotal to Snowflake, and a number of others. And we've developed quite a number of partnerships already in this space with vendors as well as system integrators. As you can imagine, this is an exciting space to be in, given what's all going on in the market right now. And so, yeah, I'm excited to be here and tell you more about Datometry and our product.
So you mentioned that you were getting a lot of attention from some larger companies here. This is not normal for startups, especially who are in such an early stage. Can you tell us why it is that you're getting this sort of attention?
Absolutely. Now, I think the biggest challenge here that we need to look at is what's happening in the market right now. And what you see is that a very well-established, large $40 billion market that the database market is today is getting completely redefined by cloud initiatives. And so this is for the first time that the entire real estate of databases comes on the market, so to speak, and within the next 3 to 5 to 10 years, this entire market will be replatformed to the cloud. So that means everybody is kind of scrambling already to kind of figuring out how to do this, because the value proposition of going to the cloud is just so fundamental, so broad. And based with this background, obviously both enterprises as well as service providers are very sensitive to the kind of technology that we develop, because it really addresses a searing pain, a very critical void right now in how people actually going to deal with databases and move to the cloud.
Now, based on my own experience moving applications from database to database, that's not exactly an easy thing to do. So what does it take to virtualize databases in this sense and allow applications to move from underlying DB to underlying DB? And how does your technology work?
Yeah, so we actually, spent quite a bit of years in this space, and very much to what you said before, it is an incredibly painful exercise. When you look, though, at exactly kind of the anatomy of a database migration or moving between databases, it is primarily a process issue sprinkled with a lot of small but really pervasive technical issues. And so a lot of people in the past conventionally move into the application and try to fix the application to now work with a different database, which is a huge rewrite, reconfiguration, recompile effort. And what we do, on the other hand, is instead of actually going into the application and modifying the application, we work completely off the network and effectively intercept the communication, so to speak, and then in real time translate that to the language and protocol of the new target database, and on the way back, do real-time translation of results to feed it back into the application. And that means the application does not change at all, and the application does effectively not even know that the database under it has changed. From a technical perspective, in a lot of ways, that is, when it comes to the real kind of translating and rewriting of things, not unsimilar to what people have done in the past. But the real kicker, and that's kind of the fundamental insight, is instead of going into the application, we just wait for the application to speak up, so to speak, and actually do this off the network. And that eliminates that whole non-scalable element of having to touch up all the applications.
Okay. I mean, in other areas of IT, what you're talking about here might be called a shim or a parser, sitting in the data path and providing the ability for an application to talk to something that it thinks it's talking to, but in fact is talking to something completely different. Now, I've seen a lot of these things work well, and I've seen a lot of them work really, really horribly. When we're talking about Datometry, how does this impact performance? How does it scale? What kind of resources does it consume? How does it integrate with everything else that we have? And what do we have to be concerned with when it comes to things like fault tolerance?
All right. Well, we're obviously our solution works very well, so no question there. But these are great questions. This is really what prospects also bring up as the first thing once they see what it is really what we can do for them. So there are a couple of interesting elements that I want to call out. First off is we really sit off the network connection. And that gives us a space that is very cleanly defined. So we're not something that you link into an application or that you need to load into the database, etc. That gives us a very clean way of operating. The second point is what we do as we translate queries on the way in and results on the way back out. We really rewrite the query text. We take the query text as it comes submitted from the application, take it apart, build a mathematical model to reason over it, optimize it. There's a lot of other things that are going on, and this diagram is obviously a gross simplification of the exact details. And then we synthesize query and protocol for the target system. All that takes in the range of 5 to 200 milliseconds typically. The queries themselves, however, run for seconds, for minutes, sometimes even hours or longer. And so the overhead that we actually contribute is tiny. Usually we don't even show up on the performance radar at all. And on the way back, as we translate results, it's a similar picture. For the result translation, if you have really beefy queries, there's probably a little more that we need to do. But by and large, we're effectively invisible simply because the actual heavy lifting is always done on the database, and we don't implement any data kind of processing or query processing in the mid-tier.
Okay, so what kind of databases does Datometry support, and what are you supporting both as the back-end database and as the application-facing interface?
Mm-hmm. So we start out with data warehousing, and that is for a couple of reasons. That's primarily around the market trends, because if you look what's going on today in public cloud, you see a lot of databases like Redshift, SQLDB, BigQuery, Snowflake, Greenplum, and AbsariDB, which really tackle the data warehousing space, because this is something that customers are in desperate need of kind of shifting the paradigm from owning technology to actually database as a service. And so that market trend is really what informed our go-to-market and our development of the product to tackle data warehousing initially. Long-term, we obviously want to kind of broaden this and really kind of fill the entire matrix here and also go after more tactical and operational database systems. But initially, it's all about the big data warehouses. And the list of data warehouses that we support right now is obviously Amazon Redshift and SQLDB, as well as Snowflake, as well as Greenplum and AbsariDB, and actually a couple of others as well. But these are really the ones where we see currently the major momentum around in the market, where people currently trying to figure out, how do I move from my on-premise database, my data warehouse, to these systems? On the application side, we're primarily focusing right now on Teradata because we see a really strong kind of market movement away from that. And Oracle is going to be the next supported system targeted currently for Q3. So that's the overall landscape here. There's another subtlety in here that I kind of already touched on a little bit. When you look at what we do, it is really between application and database. Think of it as kind of like a logical hypervisor. And to us, it actually doesn't matter so much what the database is, in the sense that, well, we need to understand the language, the properties, and all this. But for example, where exactly the database is located is kind of secondary as long as there is connectivity. And that means this solution immediately also applies to private cloud or even to other on-premises installations. But obviously, the public cloud sees currently the biggest push. Now, on to the second part of your question. What about fault tolerance, high availability, and all of these? The key element, the key insight here is that Datometry HyperQ, this is the name of our product, is per se effectively a stateless server. It receives the requests as they come from the application, transforms them, sends it down to the database, and then on the way back does the translation of results. But that means many, or pretty much all of the public clouds today, have provisions for stateless servers to scale, to integrate with virtual IP, load balancers, etc. And so we really neatly fit into this, where just taking the standard implements that cloud service providers and even on private cloud and on-premises have come up to deal with making stateless servers fault tolerant and highly available. All of this immediately applies to HyperQ. And obviously, this was one of our design goals, not having to build any of this, and also removing the configuration from kind of becoming a burden to the enterprise, but really going with standard components. So it's really kind of a plug-and-play scenario.
Okay, you've mentioned data warehousing a lot in your discussion here. Now, I'm just a simple virtualization admin, and I often have trouble sort of separating out what the different use cases for databases are, as they seem to blend together depending on who talks about it. Can you maybe talk instead about some sample use cases and use that to show us what it is that you're trying to accomplish?
Absolutely. As I said before, from the notion of data warehousing versus other databases, don't get too kind of dragged into that this is exactly data warehouses only. Obviously, this is the market force that is currently the most kind of prevalent, the strongest right now. But I want everybody to kind of think about this as a very general solution also for the general database scenarios, database environments. And as a matter of fact, later in the year, we're actually trying to come out with a couple of products that target systems outside of the data warehousing space. But you actually bring up a good point. Use cases is really what demonstrates and kind of illustrates what's going on. So let's take a look at, we have prepared 3 of them here. And I'll walk you through these and kind of tell you a little bit about the story behind these. And that kind of will give you a good sense of what it is that customers and prospects are currently trying to accomplish and what really is the value that resonates with them. So this first case is a healthcare provider, and they are generally moving from their on-premise data center to public cloud. In this case, this is Amazon AWS. And they have the data warehouse fairly happy with it, but as part of that move, it's got to go to the cloud. And this is actually another interesting little side story that in the past, database migrations were really about databases. These days, database migrations are almost always, especially when it comes to the cloud, to be viewed in the context of the enterprise moving to the cloud, and then the database is just one of the many assets that need to move. And that has changed the whole dynamics around go-to-market and how to actually deal with customer requirements. But that's just a side note here. So back to this particular prospect. They have a data warehouse that has still a couple of months, if not a year of runway on it. And at the same time, they want to already put their toe into the water, so to speak, and get stuff onto the public cloud, and then at a later point in time, want to cut over. And as you can imagine, that whole notion of cutting over is obviously very scary. There's a lot of risk involved in there. Everything else kind of is almost secondary. Money and time, whatever it takes, but the risk is just really significant. And so what this particular prospect set out to do is, I said, well, why don't we start already with setting up a DR site for our existing data warehouse and keep running this on premises, keep running this in our data center. And at a point in time where it fails, we just fail over to Amazon and to Redshift. And when you think about this, this is a very, very ingenious way of mitigating risk, because that gives them already the ability to play with the Redshift instance and do all sorts of good stuff. At the same time, allows them to run it really in 2 ways, and only having to go to Redshift initially the first couple of weeks or months when there is an outage. And so this is a great risk mitigation strategy. Now, if you try to do this with conventional means, that is not possible. So don't try this at home, so to speak, because your application, depending on which way the VIP routes it, needs to either talk to the on-premise or the cloud database. And, well, that normally doesn't work because your application can talk only to one of them. With Datometry in the picture, that doesn't matter. So you can run your application, talks nicely to your on-premises data center warehouse, and in case of an event of a failure or something else and the VIP falls over to the cloud, your application keeps running, and you're now speaking through Hypercube, still the same dialect, the same protocol, etc., but you're running in Amazon Redshift now. And so this is a fantastic way of risk mitigation and kind of gradual onboarding, if you will, into the space. I'll put a couple of numbers down there in terms of savings and in terms of the time that it took to move there and kind of get this all figured out. And if you're familiar with the space, these numbers are just effectively outrageous, because usually you spend way, way more than you save here. The $4 million is the anticipated savings. You spend way more in this in a migration, and usually a migration doesn't take 2 months. But if you're lucky, in this case, probably about 1.5 to 2 years. And so it's a fundamental redefinition of these projects. Another use case that I want to quickly survey here, quickly talk about, is a major retailer. And they are moving actually to Azure SQL DW. And in this case, the scenario is a lot simpler. They are going all in. They've done previously, before actually engaging with Datometry, they've done a number of their own testing, POCs, etc., and they felt really comfortable with getting the data there and setting it all up. Their biggest challenge here has been less the operational part, but really the fact that their retail business intelligence system is a very large custom application, so to speak, written over probably a decade or more. And just the sheer amount of queries that this thing fires off on a weekly basis, it's somewhere in the neighborhood of close to 40 million queries, is obviously, when it comes to migration, an almost impossible task. No matter how you slice these numbers, you always end up with 100+ people working for at least 5 years to change this. And that's a non-starter. People really need to move quickly as the enterprise moves to the cloud, and they just can't leave the database behind. And so for them, Datometry enabled that whole problem to go away completely with massive savings, because that's a very large customer, but also with a relatively short, well, almost impossibly short timeline. As I said before, even simple on the back of the envelope calculations gets you into multi-year, multi-tens of million dollars projects. And we were able to demonstrate to them that they can actually do this within a quarter. And as you can imagine, they were blown away. Initially, the standard reaction that we get from every customer and prospect when we start talking about these things is, whoa, this is too good to be true. This cannot be true. I've done database migrations before, and it's always going to be a big mess. And so then we engage usually in a POC very quickly. And what customers and prospects really like about this is that as the customer, as the user, you actually don't need to change anything. It's no longer your classic database POC that takes, 6-9 months or longer, because as a customer, you need to craft POC queries, you need to decide what's representative and all that stuff. With Datometry, you can actually run your actual workload, and you have very little resource usage on your end to kind of set this up. This is usually a thing of a couple of days. And then you have almost no risk, because if this doesn't work, you can always just go back. You haven't changed anything in your environment. And that is the element that really resonates with enterprise customers. Because naturally, anybody who wants to move to the cloud thinks they need to be prepared to spend years to even figure out the basic plumbing. And so this is really kind of a fresh breath of air, so to speak, for them. And since the risk in POCs and the level of involvement is so little, that makes it so easy for them to just engage in a POC, and so easy for us to convince them that it is actually possible. The last use case I want to quickly look at is an actually on-premise, if you will, private cloud use case. And that's a financial institution. And the scenario is very similar here. Their use of a private cloud is a little special, and that's why I wanted to call this out, and gives them kind of a different level of control, kind of technical details that are probably not really relevant for this conversation. They have a major middleware application in front of it, and several thousand interactive users typically hanging off this. And in this case, again, Datometry does the translation. This is a workload that is particularly heavy on stored procedures. But we also do the metering of the traffic. So there's yet another interesting element in there where thousands of connections that come in kind of get broken down and metered down to a reasonable workload onto the pivotal system. This is kind of the other side of the same coin, where just having the functional support in terms of SQL and data types is one thing, but you also need to be able to deal with the operational side. And for example, Teradata has a very elaborate workload manager, and therefore we need to give customers something that actually lets them emulate that as well. So that's the use cases I wanted to talk about. All of this, I believe, is going to be in the PDF that we distribute later on. And that, I think, gives you a good sense of what are typical ways people deploy us.
Okay, well, thank you. That's an awful lot of information. I am told that we have a short demo video which might help clear some of this up. And then I will jump directly into audience Q&As. So let's queue up that demo video and go from there.
Great. So this demo video is actually a video that a partner of ours has made, and I'll tell you a little bit more about that video afterwards.
I will type a command called btech. So btech is Teradata's native CLI. In a Greenplum database world, our equivalent would be pSQL, if you're familiar with Greenplum database. So this is their own shipping and native command line interface. I'm now going to issue a .logon command. I'm going to authenticate to Teradata, or what it thinks is Teradata, using the gpadmin account. Prompts me for the password. And we just successfully authenticated to what the CLI believes is Teradata database, when in fact it is actually, as you know, Greenplum. So the next set of steps I'm going to do here is fire off a collection of queries. If you've seen my prior Datometry HyperQ for Pivotal Data Suite demos, this part of this process is going to look very familiar to you. The goal of this step is to demonstrate both ANSI as well as Teradata syntax compatibility. So the first 5 queries are TPCDS. These are standard queries. I did not write them. They're just stock TPCDS queries. And then the last 3 queries are Teradata specific syntax I have written. So let's start going through these one after another. I'm going to copy and paste, and I'll start running these queries. Now, some of these queries spit out result sets that are longer than others, so it may take a second to get all the results to feed through. So here's query 2. I'll start and get ready for query 3. So now query 3. Query 3 is being submitted. It's already returned. Query 4. And I hope as I'm doing this, you see the complexity of the queries being issued here. These are not just a couple lines of SQL. These are fairly complicated queries with a lot of SQL syntax in them. So this is the last of the TPCDSs. And there's the results. So clearly we can demonstrate ANSI compatibility with the new Datometry HyperQ for Pivotal Data Suite offering. Next up is syntax. This query will take a second or two longer than most to feed through all the results. Okay. No from clause. And in this third query's case, this is a top-end conditional logic. By the way, for completeness sake, the first query was a group by ordinal. We did a group by 1. And this third query is the top-end conditional. Okay, so now I've demonstrated both the ANSI compatibility as well as the Teradata SQL support.
All right. Well, that's the demo. You said that you had more information to impart about it.
Well, so we started the video a little too quick. I just wanted to say a couple of sentences. So this is a video that our partners at Pivotal have made. And what you saw in there is really kind of the essence of what the whole thing is about. Run queries natively using native tools, native applications against a database that suddenly is actually not the original stack, but through HyperQ has been made fully compatible. And the demo that you've seen there is something that Derek ran on his laptop within a VM that then communicates to the public cloud. So a little bit of the latency of what you've seen there is clearly to the setup. But that is really kind of the essence, and in a nutshell, kind of, I think, really drives home nicely all the functionality and kind of look and feel as well as capabilities of the system.
Okay, thank you very much. I'm going to dive right into the questions that we have queued up here. And the first one here is that there is an awful lot of talk about born in the cloud applications And this seems to perhaps be in the opposite direction. This is taking applications that are not necessarily born in the cloud and putting them on the cloud. Does having applications be cloud native or born in the cloud versus Datometry's approach, does it make a big difference? Does it matter?
Yeah, so there are a couple of elements to it, and that is building new applications, building them in the cloud using cloud native implements, Cloud Foundry, for example, or other frameworks, etc., is obviously the way to go forward. But what do you tell an enterprise customer who has probably tens, if not hundreds of millions of dollars of application logic right now that they need to move to the cloud? And so we're actually, if you will, we're separating the problem of developing new applications versus moving. And a lot of people kind of initially are a little hesitant about this, as you can imagine, because it's really a paradigm that didn't exist in the past. It was really, well, you either stay in your data center or you move, and then you need to make a significant investment here to rewrite and recompile and reconfigure and all that. What we allow people to do is kind of really view these as two separate problems. Move your applications the way it is, move your enterprise to the cloud, be able to tap into these cloud-native databases, get the benefit, get all the goodness that comes from that, and then on your own time, decide when and how you want to rewrite or develop new stuff. Because at the end of the day, nobody has the money or the time to go back and, if you will, fix existing, running, and perfectly fine applications just because they move to the cloud. That way, we allow enterprises to really focus on the going forward and focusing their energy and their innovation really on building new applications and having at the same time the benefit of just bringing all of their existing stuff along.
Okay, I have another question here. You mentioned that you are not doing any heavy processing in the translation tier. How is it that you handle functions that are present in the original database but are missing in the new database? For example, that need emulating in the new environment?
Yeah, that's a very advanced subject. I'm glad you bring this up. So naturally, what we do is replace both syntax as well as clauses with what are equivalent implements on the new database. But very much so, there are a couple of things that cannot be expressed. And functions is a great example. So, for example, if you look at stored procedures, some of the new cloud databases do not have or do not have yet support for these. And so in that case, we actually do something fairly sophisticated. We unroll functions, so to speak, in the mid-tier, because a function at the end of the day is a stack of individual statements with a couple of local variables with kind of state to that. But they are usually transactional, and they're executed kind of by executing individual statements. And that is something that we pioneered very successfully just a quarter ago, where we actually unroll these functions and execute them for you. And that makes a couple of systems that do not have stored procedures suddenly appear as if they had stored procedures.
Okay. Another question that we have here is, if a customer were to move to a cloud database, does Datometry have best practice regarding cloud DR?
So on that front, so far we've actually gotten a lot of mileage out of the DR implementations that public clouds already offer for stateless servers in general, or also for database servers. And in all of the scenarios that we've worked so far, that has been a surprisingly effective and to-the-point solution. So the good thing here is, so to speak, that all the best practices that you've already been looking at on your journey to the cloud, how to use load balancers, how to use VIPs, how to use all of the other kind of auto-scaling groups, etc., all of this immediately applies to Datometry, and that makes the implementation and the deployment just kind of a very simple thing out of the box.
Okay. Another question, one that I actually rather like as a question here. How long do you typically execute the testing phase in order to capture all of the SQL that's being used by an application? And what about the timing? Do you test this over the course of the year and for example, make sure that you find all the yearly functions that might be at year end or quarter end or so on and so forth?
Yeah, this is a very good one. So let's briefly take a look at how we would execute a POC typically. And that is, we ask prospects to give us their query log or take our product and run their query log on, let's say, their existing data warehouse through HyperQ. And we run our product in a special mode called Query Intelligence. And that allows you to run all of your queries, simulating the execution. There's no other database system in the picture here, but just taking that workload and simulating it. And HyperQ does the whole analysis, does the whole optimization, etc., and gives you at the end of the day, and this is literally typically a day worth of work, gives you a scorecard that says, hey, these are all the things that we found in your workload. This is all the stuff that you should be aware of. And these are the things that we could translate. We even detect, for example, rogue queries that we find in every log where these are queries that have either syntax errors or referencing tables that don't exist, etc. And so we give you a full breakdown of what's going on in your box today. And that allows people kind of to immediately get a visibility into their workloads that they wouldn't get anywhere else today. You can't, from any database today, to the best of my knowledge, get that information, get kind of the breakdown of what are the features you're using, how often do you use it, the whole usage statistics. And that is usually the first step in an engagement where we tell you, okay, this is all the stuff that we found in your system, and we're confident that this will run on the other system. That's stage one, or phase one of the POC. And then the second phase is really around, well, let's just run that stuff. Let's stand up that cloud database, load some data in there, and run these queries. And when you look back about a decade ago, or a little longer than this, and I've been in this, obviously in this space much longer than that, it was really about millisecond parity when people wanted to move from one system to another. But in the cloud, this has fundamentally changed. Because, for example, if you have one query that just doesn't perform so well on that new system, you're in the cloud and you just crank up, let's say, resources, you scale, you take advantage of the elasticity. And that actually is one of the fundamental principles that we exploit, where it's no longer about speeds and feeds down to milliseconds on a specific hardware footprint, but is really about getting the value from the cloud and having that elasticity. And that has completely changed people's perception about these things. But naturally, HyperQ lets you, at basically no cost, so to speak, test drive your query workload on a completely different database. And so you get a lot of the insights as to how does this new database that you're looking to go to, how does that perform, how does it scale, etc.
Okay, I have a number of questions here about bringing the data back from the cloud, and these come in a couple of different examples, but generally revolve around if you are doing something like a DR over to the cloud, or you are temporarily attempting to burst to the cloud in order to fix something on your production system on premises. How do you bring the data back in-house, especially if you're not wanting to move the whole of the database back, but just deltas?
Mm-hmm. Yeah, so this really goes back to the use case. In data warehousing, lo and behold, you typically don't bring kind of terabytes of data back, but usually you have a ratio of very intense queries that are running for, as I said, seconds, minutes, or hours, and then typically bring back a few megabytes or a few kilobytes. And with that background, actually getting the data back, getting your answers to the queries, has actually never been an issue, because the amount of data extracted or returned compared to the computation that you executed is usually really tiny. So for data warehousing, it's actually not really an issue. This will certainly change in operational database systems, but we'll cross that bridge when we get there.
Okay, another question here is related to workload management. You had talked about Teradata having sophisticated WLM capabilities. what do you need in order to be able to do the equivalent on a cloud-native database?
Yeah, there are effectively, I believe, really two levels of that to look at. One of them is the kind of policy-based admission control. How do I get onto the system? How do I queue requests? What kind of priorities do I define there? And this is what Hyperqueue Datometry can fully take care of. We have a fairly sophisticated queuing system in there where you can define priorities, you can define even queues with exclusive access for admins, etc. And this was really driven by a lot of the experience that I had in previous jobs with troubleshooting MPP systems and occasionally not being able to do any of these things. And then the second level of this is workload management that is actually integrated into the database. For example, how the memory is being used in the database, etc. The second one is obviously outside of the reach of Hyperqueue, but we also seen that the importance of that is gradually minimized because of all the implements that you get with the cloud. Some of the cloud data players today move already even to the kind of the extreme of saying, hey, no knobs on this. You get query performance. We make sure through adaptive optimization, through machine learning, that we get you the right resources, etc. You shouldn't be burdened with having to parcel out memory or defining any of these things. And so that is something that naturally the cloud-native databases take care of. And so then we're left with, well, how do we make sure that 1,000 concurrent connections get metered onto the database in a reasonable fashion? And that is really one of the sweet spots of Hyperqueue.
Okay. Another question here is about scaling. Does Hyperqueue manage the scaling in and of itself, or do you as the administrator have to go in and manually deal with the cloud database scaling?
So right now, we're not in any way taking care of or interfering with the database setup, simply because this is something that is very often a matter of not only just scaling to workload requirements, but also a matter of billing, pricing, internal policies, etc. So this isn't something that, at least not for now, we want to take on. But then there's also all the scaling of Hyperqueue. And Hyperqueue was really designed to scale both vertically and horizontally. And by vertically, I mean you just plug in a bigger box, more cores, more memory, etc. But you can also go horizontal. And for example, put this into an auto-scaling group and then have the cloud primitives around that take care of it and fire up multiple instances of this. So that gives you scalability, at least on the Hyperqueue side, that is very easy to maintain and configure, and is way beyond what we actually seen in requirements. So far, we haven't seen anybody who needed more than one single Hyperqueue instance for scaling.
Okay, we have one question here that is from an attendee that is looking for just sort of a really quick breakdown of what Hyperqueue offers that Snowflake doesn't, and what are the advantages one over the other?
That's an interesting one. So first off, keep in mind that we are not a database. We are a virtualization platform that allows your applications to talk to, in the long run, any database. And so you make your choices as to what database you want to go to, primarily based on what's the scalability, what's the various billing and pricing models, etc. And we strive to make up the difference in features from your existing data warehouse moving to that data warehouse. Snowflake is one of the multiple systems that we support, and we're closely partnering with them. And naturally, there are a number, and this is true for every database system, there are a number of features that are just so inherently unique to the existing data warehouse, and that in a lot of cases might even be outdated because they predate standards, and newer databases implement this in a completely different way. Window functions are one of these examples. And we effectively reconcile that feature gap. Obviously, I'm not going to make any recommendations here as to what is the database system you want to go to, simply because that really depends on your personal choices, on your personal requirements. But the good thing is we effectively allow you to go to any of these and not having to worry about what your applications use today and whether this would work. It just will work. That's the simple thing.
Okay, so we have a question here about the overhead. And what is the overhead of the translation layer? Has it been measured? And what do you do about SQL statements that are precompiled using the prepare statement and into cached access plans that are repeatedly invoked?
All right, getting into the details here. I like that. So in terms of the overhead, obviously we're monitoring this closely, and we have our own kind of performance experiments for this. As I said before, this is usually in the range of a few to a few hundred milliseconds. And you need to view this in the context in which we operate, and that is data warehousing. So typically running almost any of your classic analytics or BI queries takes way longer. So from that perspective, we usually end up with less than 1% or less than 1.5% of the overhead. Your mileage varies depending on really the queries and the configuration of the system, no question about that. And the other element is really around prepared queries, and that is something that doesn't actually kind of happen too many times in data warehousing. It's really more kind of a transactional or transaction processing workload that takes care or makes use of these. Naturally, as the downstream system, as we call them, the cloud database, offers any of these implements, we'll happily use them and implement it in the same way. But if there's something missing, like preparing of statements and calling them in a parameterized way, then the query will just be submitted separately. And that usually, as I said before, that doesn't really matter so much as long as you have the flexibility and the elasticity of the cloud database, and instead of having to worry about whether a query is prepared or tuned in a particular way, you just move the slider on your console and add a couple of servers, and for $2 more for the year, you get rid of that problem altogether. So it hasn't been a problem at all in the data warehousing space.
Okay, following on from that, there's a related question. How does Hypercube break down the procedures? Is there a machine learning model to learn based on previous queries?
So right now, when it comes to unrolling functions, it's a very deterministic process. There's very little leeway in terms of what you do. And we execute these, we break them down into individual statements, and the granularity at which we do that, and the implements that we use to execute that obviously depends on the cloud database. We try to make the best use possible and optimize for whatever the new database offers us in terms of implements to work with. But it's a fairly mechanical process of doing so. But one very interesting element that is in this question, and that is actually a really important one, is naturally where we sit, being the application on our left and the database on the right of us, we're in a unique position to actually understand workloads, to build much more elaborate models than just translation, and over time learn a lot about these workloads. And we started in the last quarter with a couple of extra insights that we gained from this. For example, whether your database has specific hotspots in there, or whether you might want to replicate the database to have multiple instances to talk to. And without going into the details here, but this is information that you can learn only if you are in that kind of unique and privileged position we are in, that we see all queries go in, all data come out, and actually offer additional insights into how you might want to tune or orchestrate or deploy your database. That is an area where I think we've just kind of scraped the surface, but that offers really, in my mind, a huge potential going forward, and that is certainly something that we at Datometry want to pursue.
Okay, now there are two forces in the database market that have been around for some time. One is a drive towards standardization. Another is a drive towards feature richness. These have been around for some time, and they will conceivably continue. How do you see this affecting the work that Datometry is doing here? Do you believe it will make it easier or harder over time?
So we have naturally initially chosen systems that are in some way kind of, I don't want to say too similar, but where the expressiveness of the systems is at least within kind of an order of magnitude. For example, going from an enterprise data warehouse to a NoSQL database is a really tough move, and to the best of my knowledge, apart from any corner cases, nobody has really succeeded to make that work generally. But right now we're looking at SQL databases on both sides, and the standardization certainly helps a little bit with it, but when it comes down to SQL programmers use idioms that they're familiar with. And very often they don't know actually whether these are proprietary or standard idioms. And whatever gets the job done will be used. And so naturally we've seen this huge proliferation of kind of syntax quirks, sometimes abbreviations, special keywords, what have you. And they are typically pervasive. They are throughout entire workloads. And even though the rough structure of the query is very clear, and it's very clear what the standard way of writing these would be, it's also very clear that the slightly modified or system-specific way of writing these just makes things easier on SQL developers to kind of wrap their head around and be productive. And with that background, I believe we'll just continue to see a proliferation of these. And standardization or not, it will not be that relevant for existing applications. So that's just going to be a trend that continues. On the other hand, what I just said before, that's really kind of the trajectory of Datometry. This is really our first act of kind of acting as a hypervisor between applications and databases. But then going forward, there is so much more value that we can bring to the table, be it around the whole workload management, about security, about auditing, about compliance, all of these things, because we have our hands on the connection, because we see the queries go in and out. And this is really where I think long-term we'll be providing a lot more value than what you've seen so far.
Okay, let me sort of move more towards the systems administrator side of things here, with a bit of a nasty question that has been rattling around for a while. Are cloud-native databases really ready for this? Are they really ready to take on these enterprise workloads and these potentially very complex queries? Things like Oracle's database, like Microsoft SQL, they've evolved 4 decades longer than the cloud-native databases.
All right, yeah, this is a good one. So first off, if you look at where the cloud-native databases came from, they have, at least intellectually, kind of always had a pedigree to these systems, primarily because they were either emerging from the existing systems, or in other cases, the founders of the companies have had a decade or more experience in this space. So there's a lot of kind of informed decisions that go into these. But very much to your point, it's really just the last 12 months that we actually see uptake that is really confidence-inspiring. Cloud databases like SQL Server in Azure or on RDS have been around for quite a while. And there's certainly a solid uptake on these, but it's really a tipping point that I believe we've reached now, where suddenly entire enterprises are moving, and therefore it's no longer a matter of just the database folks to say we want to go there or stay here. It's in a much broader context, and that has accelerated this dramatically. Now, at the same time, cloud-native databases are certainly still early days, no question about this, but they've been picking up in terms of feature development, in terms of scalability and performance radically, because all of the cloud service providers and database vendors have understood this is a unique opportunity where the entire database market is just kind of in upheaval over the next 5-10 years, maybe even shorter than that. And that's a unique opportunity for them to kind of get in here and secure their spot. And if you just look at the amounts of money that the various vendors, both cloud service providers as well as database vendors, have been spending in this space, it's clear that they are banking on this And the results are also very obvious. Their systems have become fundamentally better just really in a matter of months. It's great to watch this. And compared to on-premise database systems, the beauty about the cloud-native database systems is that you're not going through these endless release cycles anymore. You get the newest, the greatest within weeks. You get these constant refreshes of hardware. You get constant refreshes of software. And that has just fundamentally kind of redefined what the database market is. So a lot of the classic cruft and risk that we've just come so acquainted with, all of this seems to be kind of going to the wayside, and people are really adopting these and moving forward.
Okay, well, we've got about 3 minutes left, so I'm going to close this off with one last question here, and it's a really good one. What about future-proofing? What happens if the underlying languages change, or the cloud provider decides that they're going to make some significant changes when, as you said, they're constantly rolling out the new versions, and you don't necessarily have any level of control over that in the same way that we do with the on-premises databases? How is Datometry going to handle that sort of change and or provide any future-proofing to developers there?
Yeah, this is a very good one, a very important one. So naturally, we were partnering with all the major players, so we actually do get a kind of a peek at what they're going to roll out or how they're going to change the product. At the same time, databases is an area where vendors have been very, very diligent about preserving backward compatibility. I'm not actually so much worried about the backward compatibility, but for example, an individual vendor might offer different database systems within the same ecosystem, and your workload should probably, let's say, not reside on the data warehouse, but should probably move over to the operational database system. And as part of what we call future-proofing, we just let you move this direction very simply and without any major pains. And so you get actually to test drive some of these things. Another element here in the future-proofing is, as these systems are on a rapid development, the way you would rewrite a query today to meet, let's say, version 1 of that cloud database might be very different than version 2. And in version 2, there might be a much more elegant and much more efficient and effective way of rewriting things. And so if you do a manual migration today to version 1, you're basically back to square one, because as version 2 comes out, well, you would have to go back and now re-platform to version 2. And again, we just remove that burden from you. You just plug in there, you run your existing applications as is, and you just move forward and rev the database, rev the system that you want to go to. That makes it very easy.
Excellent. Well, thank you very much, Mike. I know that I've learned a lot during this. I'd like to say thank you very much to all of the attendees and to my colleagues at Virtualization and Cloud Review for hosting this. I hope everybody has an excellent day, and I hope to see you again at another Fireside Chat.
Thank you, Trevor. You guys did a great job today, and I'm sure the audience really enjoyed it. And we really appreciate you guys taking time out of your busy schedule to be with us. And is there anything either of you would like to add before I close out the event?
Well, thanks for hosting us. I think this was a really great conversation. Thanks, Trevor, for some of these nasty questions. And I hope we could really shed kind of light at what we think is really a redefinition of the entire database market. There's obviously more information that is out there on our website, as well as a couple of outlets already. And at any point in time, we'd love to interact with you to answer additional questions.
Very good. Thank you so much. And I'd also like to thank the audience for attending today. The webcast was sponsored by Datometry and presented by Virtualization and Cloud Review. Thanks again, everybody, and enjoy the rest of your day. Bye-bye.